So you all may need to press a button to approve that. These the videos of these sessions, of all three sessions, will be available on the College Church website and on the Vertical 101 YouTube channel. And Dr. Randier will also have them available. So I'm going to turn it over to Pastor Bill Hodgman, who's in mourning for the Patriots, as we can see. He'll introduce Brian this morning.
Yeah, good morning, everybody. Thanks for being here. I do get to be the pastor of College Church, and to me, this is a wonderful example of how faith and science serve each other. And so I'm looking forward to being challenged to think and live well about these topics. This is part 2 of a 3-part lecture series on the Christian faith and our ecological crisis, and it's co-sponsored by Vertical 101 and College Church and Dr. Timothy Randier from the Department of Environmental Conservation over at UMass in Amherst. And this particular lecture is called A Christian Perspective on a Planetary Crisis. Our presenter, just as he was last night, is Brian Webb, and Brian serves as the director of the Center for Sustainability and is an assistant professor of environmental studies at Houghton College in New York. And so far under his leadership, the college has reduced its carbon footprint by 32% in just 10 years. So Brian practices what he preaches. So welcome, Brian, and thank you.
Thanks so much, Bill. Really glad to be here with you guys again today. I recognize most of your names or faces, I think, from last night, with maybe a few new people. But really looking forward to our talk here together. Let me just set up the share screen so I can get it started here. All right. So we're going to be talking today about one of my favorite topics. I think I probably said that last night too, but Chris invited me to talk about my favorite topic, so it works out well. And really, as sort of Bill's introducing this faith-science connection, I love when we're able to really dig into that and explore what it looks like for people of faith, and in this particular case, talking about Christian faith, what does it look like to explore some of the important scientific and environmental topics that are going on in society today? But I want to start off, and I'm going to try something a little bit new here, and I haven't actually done this before in a presentation. Oops, where are we going here? Yeah, there we are. I want to try a little live poll. So if you're in front of your computer, you can pull up a browser, or you can use your phone and text this, but this should give us live results to your responses here. You can text Brian Webb 701 to that number there, and then just put what letter you want to respond to. I'm trying this out, seeing how it works. You've probably seen these interactive polls before in other presentations. I keep thinking I've got to add these into mine sometimes. So you guys are my guinea pigs here. I think it should be live, yeah. Hopefully. Has anyone entered their response so far? Okay, good, it's working.
Let me question, Brian, what if you don't have a smartphone?
You should be able to do it on your computer as well at pollev.com/BrianWebb701.
Yeah, that's the dummy, I didn't see that.
Yeah, there you go. Oh,
You're challenging my computer skills this morning.
Sorry about that, Chris. But it's not showing me his number of responses. That would have been helpful. All right. All right, so looks like about split equally between extremely concerned and somewhat concerned. Yeah, there's good reason to be concerned about the state of our planet today. And that's what really we're going to dig into here in our discussion. So for part 1, for the next hour, we're going to look at a Christian perspective on a planetary crisis. I'm going to start with, for those who were with us last night, with a very quick review of the content that we talked about last night. For those who didn't join us, this first section, you can get a much more thorough discussion of that if you watch last night's recording. And for those who were here last night, don't worry, I'll go kind of quickly through it, and it's reorganized a little bit differently, so maybe it won't feel like complete repeat. Next, I'm going to give a bit of a broad overview of the state of the world today on a broad scale. And then we're going to dig down deep specifically into the climate crisis, and particularly for understanding the science behind what's happening and the impacts on how humans in particular. So we're going to focus particularly on how humans around the world are being impacted by climate change. Then in our second hour, starting at 11 o'clock, this first hour is a little bit of the downer message, the things that are wrong and messed up in the world. Don't get discouraged and depressed on that, because there are good solutions and things that we can do about it. And that's what we'll talk about the second hour. But I'm starting that off with looking at 5 specific phenomenon that help explain why all of these kinds of big problems, particularly environmental problems, exist here. Talk a little bit about some of the specific climate complexities around that topic, and then look at climate solutions, both from a global, a governmental, and an individual level. Okay, so let's start and look briefly at a biblical foundation for creation care. Again, if you want to explore this more thoroughly, check out the recording from last night. But looking in scripture, we see in the beginning, in Genesis, right from the start, God sets up a really nice kind of template, if you will, for what environmental stewardship can look like for humans. So it begins by declaring that the creation is good. And not only is it good, but it's intrinsically good. God declares each element of creation good before humans ever enter onto the scene. And then reflects back on all that he has made. And behold, it was very good. All that God made was good. God covenants with the creation itself. In Genesis 9, what we think of as the covenant with Noah is a bit of a misnomer there. It's not actually a covenant with Noah. It's a covenant with Noah and his descendants and every living creature on the earth. So God's covenant that he makes is with every living creature on the earth, because God cares for every living creature on the earth. Humans have a responsibility. We see that in Genesis 1:28 in the form of dominion. And dominion has often been misunderstood to be domination or to be doing whatever we want. But a biblical view of dominion is much more in line with an idea of stewardship or leadership or service. God's model of leadership tends to be one of humility and service that we see in scripture. So dominion, I think rightly understood, is much more in line with this idea of working and taking care of, which we see in Genesis 2:15. The Hebrew words abad and shamar, to tend and to keep what God has made. In the law of Moses, we see that creation belongs to God. To the Lord your God belong the heavens, the earth, and everything in it. And that creation has standing. There are all kinds of laws in here for the Israelites to protect what God has made and to honor what God has made. The Sabbath, 7th year of Sabbath rest for the land itself, or don't pollute the land that you live in. In the books of poetry, we see creation glorifies God. Lots and lots of great psalms talking about the earth rejoicing or the trees singing. Look at Psalm 48. The whole psalm is just a fantastic and beautiful picture of God's creation, bringing praise to him. God cares for his creation. The Lord is good to all. He has compassion on all he has made. In his hand is the life of every creature and the breath of all mankind. You care for the land and water it. You enrich it abundantly. God cares for what he has made, not just for humans, but for the natural world as well. In the Gospels, we see the lessons of servant leadership, where Jesus echoes numerous times that leadership is about service. It's about putting others above yourself. It's about the first being last. We also see that God has special concern for the lowly and marginalized parts of creation. We see this very clearly with how he approaches individuals, people. You think of the Samaritan woman at the well, or the woman subject to bleeding. But also see this with his creation as well. Are not 2 sparrows sold for a penny, yet not one of them falls to the ground outside your Father's care. God cares even for the individual sparrow. And love your neighbor. The idea, when Jesus was asked, what's the most important thing in the law? Love the Lord your God, number 1. Love your neighbor as yourself, number 2. And as we will dig into this morning, there are very significant connections between environmental stewardship and loving your neighbor. So the biblical concept of love your neighbor could perhaps be the strongest argument for environmentalism in either the secular or Christian world. I think there really is no stronger argument for environmental stewardship than the biblical concept of loving your neighbor. And in Paul's letter, we see Jesus at the center of the creation story, that through him all things hold together, all things were created for him, not for us, for Jesus. And that God's ultimate plan is to redeem creation, to reconcile to himself all things, that creation itself will be liberated, that redemption and reconciliation are part of God's ultimate plan. So what we see is a consistent trajectory of stewardship and concern for God's creation throughout the scriptures. I know this was just a brief overview through that, but through the arc of scripture, we see again and again God's concern for the creation, his loving it, that God gave humans a special role, a unique role of stewardship and responsibility here, and that God's plan is redemption, and that we can be part of that plan of redeeming and restoring creation as we steward it out of love for our Creator and respect for what he's made. So how's the world doing today? Let's look at what's so unique about this particular moment. Environmental concern is not new to this moment in history, but we'd certainly live in a bit of a unique time right now. So why don't you put up in the chat, or if you want to unmute yourself and give quick comments here, how has the world changed in the past 200 years? What would you say? What's changed in the world in 200 years?
The Industrial Revolution.
Right. Industrial Revolution changed a lot of things. Globalization, more greed. Rapid international travel, concentration of power, deeper inequalities, good transportation, population. Great, good answers there. Let's just, whenever I click on the chat, it's hard to go back. Okay, let's pick out just a few variables to look at. So we've gone from about 1 billion to almost 8 billion people in the past 200 years. So pretty fast growth there. Average home size has increased 5-fold in the last 200 years. We have 1.4 billion cars on the planet now, obviously none 200 years ago. 200 years ago, most people spent their whole lives in one location. Traveling, moving wasn't really a thing. Today, the average American moves 11 times in their lifetime. And we currently use 22,000 terawatt hours of energy per year, which is the equivalent of 1 million Hiroshima bombs of energy for our electricity needs. In other words, there's a whole lot more people in the world today living in larger homes with more stuff, using lots more energy and moving around a lot. It makes sense that the impacts we have on the environment are quite a lot more today than they were 200 years ago, because there's simply a lot more demand being asked of the world around us. Population growth has grown exponentially to the point where we have a lot of people in the world today. And fortunately, the population growth has slowed. Growth actually peaked in the 1960s, and the growth rate has been declining since then, which is good news, to the point where now the average fertility rate in the world is about 2.5 children per woman. So the population is still, world population is still growing, but it has slowed quite a lot. And actually the good news, many people get uncomfortable with conversations about population growth and environmental concerns because we tend to think of the more draconian population control measures. A, those don't really work. And B, they're not the best solution anyways. Really what we find is that the number one best way to slow global population growth is to empower women in the developing world. Empowering women in the developing world through access to education and jobs is the single best way to slow down global population growth. Because when women have education and have access to jobs, they tend to have fewer children, they get married later, they have children later. And that ends up both being good for development and addressing poverty and inequality, but also for addressing the environmental concerns that come because of global population growth. So the answer to exponential global population growth is empower women. So I always like to dispel that concern, particularly for Christians who get worried about where are you going with this population thing. Correspondingly, we use a whole lot more energy than we used to. Coal, oil, gas, particularly over the last 70 years, you can see how it has skyrocketed up our demands for that. These are all energy sources that used to be hidden into the ground, located down there. And now we have accessed those, we are burning those. And of course, that is causing a lot of problems, pollution problems and greenhouse gas emission problems. But the rate of use of that has increased very significantly in recent years too, along with a whole bunch of other things as well, not just energy that's going up exponentially, but we see it across numerous socioeconomic trends, whether it's water use or paper production, fertilizer or transportation. All of these activities have significant demands upon the natural world around us. So when we see these things going up very quickly like this, that is an indication that our demand that we as humans are putting on the natural world is also increasing significantly. And correspondingly, we see Earth systems are being impacted at increased rates. Land use or forest loss, ocean acidification, and greenhouse gases, all of these are also going up very rapidly as well. That, of course, leads to significant population declines in wildlife, 68% decline in wildlife populations over the last 50 years, mostly from habitat loss and overexploitations. Also, pollution and climate change play a role as well, as do invasive species, but most of that is from habitat loss, simply because the human footprint is much bigger than it used to be. And as the human footprint grows, the space for wildlife population decreases. Species are going extinct 1,000 times faster than the natural background rate. So the natural rate of extinction, we're currently exceeding that by about 1,000 times in terms of the rate at which species are going extinct, which leads many scientists to say that we are entering something called the sixth great extinction, a time when human actions, the human species, is causing such massive amounts of extinctions that it's really threatening the biodiversity on a planetary scale. Rainforest deforestation, highly problematic. We've lost about half the world's rainforest since the 1960s, particularly in the Brazilian Amazon and in Indonesia and Southeast Asia. There are significant losses, rainforest losses there. And there's a reason why we call it the Amazon, the lungs of the planet, because there is so much oxygen stored, so much carbon dioxide sequestered here. The photosynthesis process is so important that the Amazon plays, and losing massive amounts of rainforest where half the world's biodiversity is located is really problematic on a global scale, not just for the Amazon itself. There's a whole lot of plastic in the ocean. The Great Pacific Garbage Patch is more than twice the size of Texas and is filled with a whole lot of bits of plastic, many of them very small pieces of microplastic that don't ever degrade, or if they do, it's many hundreds to thousands of years. And it's not surprising, since we use 1 million disposable plastic water bottles every minute, that we would have a significant plastic problem in our oceans. And that doesn't even get into a whole host of other environmental problems and challenges that we see around the world as well. Now, this graph I find super interesting. I debated whether to put it here because it's a little bit complicated. But if you can look at this here, the bottom, the x-axis looks at Human Development Index. So HDI is a measure of overall well-being based upon income and health and education levels. So the further to the right a country is, the better off that country is. All the dots represent countries in different world regions. The y-axis looks at the number of Earths it takes to satisfy the resources of that country if the whole world followed that pattern. So for example, the United States is probably one of these blue dots right here. Not totally sure which one, but one of these blue dots is the United States. In other words, let's say it's this one. If the whole world lived like the United States, we would need about 4.5 planets to satisfy the demands that we're asking from a natural resource perspective from the Earth. So the problematic thing here, as you'll notice, obviously we want countries to move to the right. We need them to move to the right, because down here, where most of the African countries are, this is poverty. This is bad. This is, we don't want people to be here from an ethical and a human rights and a Christian care perspective. We don't want countries to be here. But the problem is when they move to the right to develop, they also use a lot more resources. As we live in our own society, we know about how much resources we use. It's a lot, and it's not sustainable on a global scale. So this is, in a picture, a bit of the problem that we're facing as a society, that as countries develop, they also begin to ask too much of the earth that can't be sustained over time. And this is the trick that we have to figure out what to do about. All of this has led many to postulate that we are entering something called the Anthropocene epoch. Geologists look back on historical epochs in Earth's history, and they're saying that we're entering a new epoch, and it is defined by human disruption of Earth's systems, is the defining characteristic of where we are in sort of a geological history today. In other words, remember that stewardship conversation we started with? We're not necessarily doing a very good job of it at the moment. Now, let's dig into and look specifically at the topic of climate change. In large part, obviously, this is a big topic in society and in the world today. And most scientific experts or environmental experts will say that this is the most important environmental issue, and perhaps even one of the most important scientific issues today, in large part because it exacerbates so many other problems in society, not just environmental problems, but health problems, human rights problems, all kinds of other social and political challenges that we face in the world are exacerbated by this. So it is kind of the grand challenge that we're trying to face as a global society. So let's look first at how, we're going back to like high school geology, biology class here, and we're going to talk about the greenhouse effect. So how the greenhouse effect works. The sun's energy, solar radiation, enters the Earth's atmosphere, warms the planet. That energy is re-radiated back out towards space. Some of it escapes, as you see from this arrow here. Some of it is trapped by this blanket of greenhouse gases in the atmosphere. Carbon dioxide, water vapor, methane. These are all greenhouse gases. It's a really, really good thing that God made our planet with greenhouse gases in the atmosphere. That's important to realize because those greenhouse gases trap some of the heat that's re-radiated and hold it in like a blanket does over you at night. Without that layer of greenhouse gases, does anybody know? So the average temperature of the Earth is about 60 degrees Fahrenheit. Anybody know what the average temperature of the Earth would be without any greenhouse gases? Somebody want to throw that up in the chat? Take a guess. If we didn't have this blanket of heat trapping gases in our atmosphere, minus 40, not quite that cold. Good guess. Colder than 20. About 0 degrees. We would literally, yeah, there you go. We would literally be a frozen ball of ice that is inhospitable for any life if we didn't have that blanket of greenhouse gases in the atmosphere. So that's super good that we have that. The problem is we have too much of it. So as we are burning fossil fuels, when you burn coal, oil, or gas, the byproduct of that is carbon dioxide. This is a very simple and obvious thing. You can demonstrate it in the building adjacent to mine. It's a simple scientific experiment to be able to measure that carbon dioxide is the byproduct of burning coal, oil, or gas. So those CO2 molecules go up in the atmosphere. They stay there for about 100 years, by the way. It takes about 100 years for them to fall out of the atmosphere. So essentially what we're doing is we're thickening the blanket. So we're putting a thicker blanket of heat trapping gases into the atmosphere, which means that that thicker blanket allows less heat to escape to space. More heat gets trapped and captured and warms up the planet. That, in a nutshell, is what global warming is. Global warming is essentially this, us thickening that blanket of heat trapping gases around us primarily by burning fossil fuels. And as we noted, we're doing a lot of that. We're doing a lot of the burning of fossil fuels. In fact, we have exponentially increased the amount of fossil fuels that we have used, particularly over the last 70 years, since the Industrial Revolution, but especially since 1950. Have rapidly increased that. And as you would expect, we correspondingly see a significant increase in CO2 concentrations in the atmosphere. We've been taking direct measurements since 1958 at the summit of Mauna Loa in Hawaii, because it is a great location for isolating that from other variables around. And we see continued uptick every year. We're up to about 420 parts per million now, from a pre-industrial average of 280 parts per million. Anybody know why it has this up down every year? Every year it seems to go up down, with an obvious upward trajectory overall, but there's kind of that annual variation. This is where I would offer extra credit for somebody who gets
It looks seasonal.
Yep, seasonal. So where is most of the vegetative matter on our planet? Most of the trees?
Probably most of the trees. Oh, that's a good question. Probably in the southern hemisphere.
Actually, it's the northern hemisphere. So there's
Really?
much more land mass in the northern hemisphere. And particularly when you look at Russia, Canada, US, places with extensive forests. So most of the plant matter is all in the northern hemisphere, which means that in the summertime, when the leaves are out, the plants are growing, they're sequestering additional carbon dioxide. So that's when it dips down. And then in the winter time, when they lose their leaves and go dormant, it shoots back up because they're releasing a lot of carbon dioxide back to the atmosphere. So good guess. Clear upward trajectory that we're continuing to see. And correspondingly, same thing with temperatures. Temperatures are continuing to go up and up and up and up. This is compared to a 1970 average, I think. You see a clear trajectory of it getting warmer and warmer each year. This looks at it from about a 2,000 year schedule. You see, actually, for a long time, we were starting to kind of get colder. And then all of a sudden, right around the Industrial Revolution, and then really picking up, and that sort of post-war boom from the 1950s, we see skyrocketing temperatures going way up. And the 10 hottest years have all been within, all since 2010, 10 hottest years on record. We just continue to make more and more records. This past year was number 6 on the list, but the previous year, 2020, came in number 2. 2016 was an El Nino year, so it went up even a little bit more than usual then. But the past several years have continued to set records and continue to set that trend. The other thing that's useful to know, this is not a new discovery. Al Gore didn't discover global warming, unlike what some people would like to say. We've known about this for a really long time, coming up on almost 200 years since Joseph Fourier discovered the greenhouse effect. So we've known about this heat trapping blanket for almost 200 years now. Eunice Foote actually was the first person. She was a largely unknown amateur scientist from Western New York, actually near me. She was the first person to measure the heat trapping properties of carbon dioxide. So she actually, as an amateur scientist, measured this. It was just a few years after that, the English chemist John Tyndall confirmed that discovery as well. We don't even have a picture of Eunice Foote. I have been unable to find one, largely because she was a woman amateur scientist in the 1800s. John Tyndall demonstrated how greenhouse gases capture heat. And then the Swedish chemist Arrhenius made the first calculations of how burning coal would warm the atmosphere by hand, actually. And his calculations were surprisingly accurate. So even it's been since the 1890s that we've been making calculations about how burning fossil fuels warms the atmosphere. None of this is new. We've known the science for an extremely long time. Oh, anybody want to guess the first US president to have been briefed about global warming? Who do you think is the first president who got a scientific briefing about global warming? Oh, you guys are going too far back. Roosevelt, Coolidge, Lincoln. No, it's Lyndon Johnson. Lyndon Johnson was the first one to get an official briefing about that. But so that's the 1960s. It's not like Al Gore brought it up. It's not like it's just in the 2000s that we started talking about. Going back all the way to Lyndon Johnson, there were official briefings at the White House level on this. So we've known about it a long time. There is significant scientific consensus around this. Somewhere between 97 and 100% of scientists agree. There's a lot of different studies measuring this, but the short of it is that the experts all agree, yes, humans are causing global warming or climate change, that it is indeed clear. Every national or international level scientific society in the world agrees with this assessment. So every major scientific society on the planet agrees with the assessment. And the latest IPCC report, Intergovernmental Panel on Climate Change, this is a massive, massive scientific undertaking. There is no corresponding equivalent for this report in any other scientific endeavor. This is many hundreds of climate scientists from dozens and dozens of countries around the world that look at tens of thousands of scientific reports and basically pull in a condensed analysis of our state of knowledge of the climate system based upon all the best science. And then every government in the world that is party to the United Nations Framework Convention on Climate Change, which is every government in the world, has to sign off on this scientific report. So not only do you have hundreds of the world's best scientists collating all of the peer-reviewed scientific information about climate change, then you have every government in the world signing off on the report. And the most recent report, August of last year, states it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Scientists don't use the word unequivocal almost ever. If you know anything about scientists, ask Tim. The word unequivocal is not one that is very frequently used because it really opens yourself up to criticism, but that is the significant level of agreement within the scientific community around this topic. And that's profound and important to realize. Okay, we're going to do another one of these polls here. This one is a word map. So you might still have it open. Oh, I haven't activated this yet, so don't put it up there yet. Hold on, got to, oh, not that one. Okay, I think it's active now. So if you still have it pulled up, go back into that text stream again, or to that website again, and put up there, how does climate change impact humans? Try to make it a one word or maybe a hyphenated 2-word answer on there. These word maps work better if it's just one word or a hyphenated 2-word thing. And you can put multiple entries here. So they get bigger as multiple people mention them. Great, yeah, drought, displacement, poverty, yeah. Crop failure. Floods, overheating, more extreme weather. Yeah, great. You guys are not new to this game, I can see. Lots of great answers there. All right, well, looks like drought's the winner. I should move on, but these things are so captivating. Superstorms, yeah. We got a Superstorm Sandy picture there. You guys may remember that. Oh, political stress. Wow, cool. Okay, good. I'm moving on here. Whole lots of ways. You hit on some of the highlights, some of the key ways that climate change is impacting humans. We're going to breeze through these as well. Heat waves, more frequent. This looks at the city of Buffalo. 85 degrees may not sound like a lot if you live in Georgia, but if you live in Buffalo, like I do, and you don't have air conditioning like I do, 85 degrees is really uncomfortable in your house. But by and large, we're seeing more and more heat waves in many places around the world. And these are not things that we necessarily notice on our own, because look at this pattern. Some years is warmer, some years is colder. But if you look at the trajectory over time, you see a consistent trend of it getting warmer and warmer and more heat waves happening. This is a study published 2 years ago in the National Academy of the Sciences, so one of the most prestigious journals that's out there. And what you're looking at, so it's obviously a global map. These black areas here are areas of the planet that are too hot for humans to live in. Basically, it's not conducive to human life, I think is how they define it, because of the temperature. So right now, it's not a lot of places, right? It's like the heart of the Sahara Desert, a little bit on the Arabian Peninsula. It's not most places. By 2070, if we continue on the trajectory we're on currently, by 2070, this dark red shaded area will be the area that has the same temperature pattern as this black area here. In other words, all of this dark red shaded area will be places that are inhospitable to human life. This is where 3.5 billion people live. This is most of India. This is most of the Amazon basin, tons of Southeast Asia, a huge chunk of Africa, almost the size of the United States, inhospitable to human life. That's a big deal. This is on the trajectory that we are on right now, within the lifetime of my children, that this much of the planet will be inhospitable for human life if we continue to heat in the way we are. Wildfires are getting bigger. You may remember the Boulder, Colorado fires just last month. This was wintertime fires. This is not fire season. December is not fire season in Colorado. The suburbs, the heart of the suburbs of Boulder are not places you expect wildfires to happen. But because the fall was really, really dry and really, really hot in Colorado, those fires were worse and caused a lot of damage. Wildfires happen. They happen without climate change, but once you factor in, scientists have been able to quantify the role that climate change plays. The damage is much more extensive because there's more of them and they're worse and they spread faster. Hurricanes are stronger. Climate change does not cause more hurricanes, but it does make them more powerful because hurricanes derive their strength from heat. If you think of in the science lab, when you're a chemistry student doing experiments, what do you do to a formula in order to cause a reaction? You add heat to it, right? So heat is energy. The more heat there is in the ocean, then the stronger the hurricane becomes because that's where it gets its energy. And the more heat in the atmosphere, the more moisture that hurricane holds into it and dumps down, which is why we saw record-breaking rainfalls with Hurricane Harvey in Texas. Part of it's because a low pressure system kept it there for a long time, but part of it was because there was so much heat in the atmosphere that it condensed so much moisture and just allowed it to dump down. So hurricanes are stronger, causing more damage. Somebody mentioned extreme precipitation. One of the things that we're seeing is that rainfall, for example, is in many places happening less frequently, but in more intense outbursts altogether. So these kinds of extreme precipitation events are really not good from an agricultural perspective, because when you get a whole dump of rain at once, much of it washes off and doesn't soak into the ground. So you end up places being dry for a really long time, and then an intense rainstorm comes, and that's really damaging from an agricultural perspective. Droughts are stronger and longer. That's pretty easy to imagine why that's the case when you have warming. The ocean is acidifying. We don't have time to go into the details of all of that, but the essence being that chemical reactions with CO2 getting absorbed into the ocean are changing the pH balance of the ocean and are literally destroying coral reefs. As Chris's daughter can tell you, who works on this for a living, there's a very good chance that my grandchildren will never be able to see a coral reef because they won't exist on this planet anymore, because in large part because of the pH changes going on in the ocean because of the CO2 in the atmosphere. Now, hopefully Chris's daughter can fix that for us and many other great scientists working on it. But right now it's not looking particularly good for many of the coral reefs around the world. This man right here is named Tafue Lusama. Tafue is a friend of mine, and he is a pastor of a church in the island nation of Tuvalu. This is a picture of the main island in Tuvalu. It's a very small country, one of the smallest in the world. And Tuvalu is, as you might imagine, being lost to sea level rise. So as sea levels are rising through melting glaciers, melting ice caps, and thermal expansion, which is when water warms, it expands, takes up more space. So between the melting glaciers and ice caps and thermal expansion, sea levels are continuing to rise. And most say that they will rise probably between 0.5 meter to 1 meter this century, but potentially could rise several meters. There's a whole lot of variables in there that we're not quite sure how it will come about, but at least 0.5 meter, maybe as much as 1 meter. If sea levels rise by 1 meter, the island nation of Tuvalu will be completely underwater, completely submerged. So his nation is making evacuation plans, national level evacuation plans for how can we evacuate our people to a new homeland, a new country, which is a really profound thing to think about. How do you move an entire country and people group to a new place? And how does that become their home? And what about their ancestral home and the things that they have lost and left there? So Tafue, who's a pastor by trade, goes around the world talking about climate change in order to bring awareness to the plight of his people. He has been a UN delegate for many of the UN climate conferences, and a great man. But yeah, sea level rise, it's a big problem. Food production impacts vary by region. This is one of the few areas where there are some positives, but still more negatives than positives. Positives for places like where we live, because longer growing seasons are helpful for New York or Massachusetts. So there's some initial benefit to warmer weather in some places, more the temperate regions. But there are immediate and significant downsides in the equatorial regions. So equatorial regions where it's already very warm don't need more heat added to their agricultural production, because that's bad for it. In fact, already the Bread for the World, great Christian food aid organization you may be familiar with, put out a report about 5 years ago. So global hunger has been decreasing for decades. We really have slashed global hunger significantly. It's down to about 800 million people hungry, which is still way too many, but way less than it used to be. For the first time 5 years ago, it started going up again. And Bread for the World and many other organizations point to two factors contributing to an increase in global hunger. One being conflict, because there's been a lot of conflict around the world, and conflict's bad for hunger. And the second one being climate change, that the impacts caused by climate change are causing agricultural production to decrease, particularly in the equatorial regions of the world, where poverty already is fairly significant. Increasing air pollution. Heat is bad for things like smog and other forms of air pollution. It really contributes to a lot of cardiovascular problems, asthma. All of this is exacerbated by heat in the atmosphere and is really problematic from a human health perspective. Infectious diseases are spreading. Malaria, for one, we're working really hard to combat malaria around the world, but climate change is really doing a lot to try to fight our efforts to combat that by spreading it more. Lyme disease, obviously, you're no stranger to Lyme disease where you live, nor are we here, but we used to be. Where I live in New York, 1996, Lyme disease was almost unheard of. Now I know lots and lots and lots of people, I'm sure you do as well, who have had Lyme disease, and many people who have really been knocked out by it for months or even years. I could name half a dozen people who have had long-term problems with Lyme disease. The connection between Lyme disease and climate change is that winters just aren't getting cold enough to kill off the ticks anymore. It used to be that cold winters would knock their populations back, which is why it was largely along coastal regions where it's a little milder. And further inland, you didn't see it as much because it would get colder. Well, now it's not getting as cold in the winter. And so you're seeing a lot more ticks surviving and a lot more Lyme disease spreading. It's very costly. Climate change is impacting the economy in a big way. I won't read all of these titles and statistics for you. The short of it is that climate change has significant economic costs to society, and there's a lot more costs we're facing because of the ways that climate change has negatively impacted on us compared to the cost it would take to address this. It would be much cheaper to invest the money now, solve climate change, and avoid all the costs that would be coming. So who does climate change impact? The short of it is yes, everybody is impacted in some way. I'm sure you guys remember Superstorm Sandy. Did that impact Central Mass in a big way? Sandy, 10 years ago? Not as much, okay. Certainly being here in New York, we remember it well, or New Jersey. The reason why Sandy was so devastating was because the Atlantic waters were so warm and allowed it to grow to 1,000 miles wide, the largest in size Atlantic storm to that time. We see it impacting all over the place through increased heat temperatures. This is my daughter, Katie. She got Lyme disease while we were backpacking in October. Usually ticks are gone by October. Fortunately, we caught it early. She's fine, but I know many people who aren't fine because of that. So my family, yes, has been impacted by climate change. Hurricane Harvey, we mentioned, the massive dumps of rainfall in Houston or California wildfires that we've seen rampaging lately. So climate change impacting all over the world, including in the US, including where we live here. Unfortunately, those who are hit first and worst by climate change tend to be impoverished people and people of color. When you look at who gets hurt the most by climate change, it tends to be less developed nations around the world. It tends to be people in poverty, and it tends to be people of color who are on the front lines of climate change impacts. So yes, it impacts everybody, but unfortunately, the ones who are most hurt by it are the ones who are least able to respond to it, and those who are already marginalized in society. So from that perspective, there is a significant justice component related to how do we look at this issue, not just as an environmental issue, but as a human issue and a justice issue as well. I'm almost done here. Look at with me just a couple more maps. This looks at climate vulnerability on a global scale. So it takes into account both the impacts, the places that are most severely impacted by climate change, but also the human capacity to respond to that. So in the US, we do see a lot of climate change impacts, but we're also a very wealthy society. So we have the capacity to respond. And so we're not as vulnerable in the end. Places like sub-Saharan Africa are both on the front lines of where the impacts are happening, but also have less capacity to respond to that as well. So the redder it is, the more vulnerable. Now, we're going to shift to another one, and we're going to keep this map here, and I'm going to juxtapose it with another map on top. This looks at carbon dioxide emissions per capita, per person. So you tell me, what do you observe as you compare one map with the other? On the top map, the redder it is, the more CO2 emissions there are. The whiter, the less CO2 emissions. What do you observe here?
Yeah, those who are causing the most problem are the least affected.
Yeah, absolutely. The countries that have the highest emissions tend to be less vulnerable. And vice versa, the countries that are doing the least to contribute to it tend to be the most vulnerable. So this is when I look at this is where my faith really comes into it for me. As a Christian, I am really not okay with this reality. This bothers me significantly because I sit in this deep red country here. I am highly responsible for contributions to carbon dioxide emissions in my lifestyle. And yet those emissions are most severely hurting people who are the least responsible for it. This is really problematic from an ethical perspective, from a justice, from a Christian perspective. And by and large is the main motivating factor for me on why I care particularly about this issue. Last slide here, and then we'll take a break. You can just kind of look at this. So this looks at CO2 emissions over time by a few highlighted countries. This is the world right here. You can see a gradual increase here, but look at the differences between some of these. United States up here, we're not the highest. There's a few of the oil-rich nations in the Arabian Peninsula, like Qatar and Kuwait, are higher than us. But among wealthy nations, we're at the top. Sorry, among like the larger, more developed nations. A lot of people bring up China. Yes, China's greenhouse gas emissions in total are more than ours, but their per capita emissions are less than half. So on a per person basis, they're a whole lot less than we are. European Union, which has the same standard of living as us, way less than us as well. We're pretty high. We have come down from our peak, which is good. So that's nice. But we're still way up higher than we should be. And then compare the US to Africa or India, and it's just not even the same ballpark. If you were to put Tuvalu up here, it would be way down near the bottom as well. So really, really problematic. All right, we're going to stop there. I know that's a bit of a downer one, so hang on, because in just a little bit, we're going to get to the good news and the solutions and the things that we can do about it. So don't be depressed yet. But sometimes I find that it's helpful for the weight of our problem to settle, so that we can understand the gravity of the situation we're in and then move to here's what we do about it. Here's how we can respond. Okay, I'm going to stop there and give you guys a chance to ask questions.
So I had a question, Brian. In the last chart that you put up,
Yep.
if you look at Russia, there was a very rapid decline in CO2 emissions. It was enormous over a short time period. What caused that?
That was the fall of communism. When the Soviet Union broke up,
The economy
yeah,
collapsed.
the economy collapsed. And there's such a direct connection between economic activity and greenhouse gas emissions. So the trick we're trying to do in the world today, we're trying to decouple that connection so that you can have economic growth without greenhouse gas emissions. And we'll get to that in a little bit on how we do that. But that's the problem. That's exactly what you're seeing there. When their economy collapsed, their emissions went way down.
Right, I don't mean to step on your next lecture if you get into this, but what is the EU and the UK doing so differently from what we're doing?
There's a number of different factors there. Individual car ownership is much less there. So lots of people don't own vehicles, or most families own just one vehicle. So transportation wise, there's a lot more public transportation use. House size is smaller in the UK and in Europe. People live in more densely populated areas. Actually, it's much more sustainable to live in a densely populated city than it is in sort of the American system of suburbs and such. So the way their lifestyles there, there's more environmental awareness in Europe and in the UK. And so there's a kind of greener lifestyles in general. So all of those factors kind of pulled in together lead towards lower emissions overall. Europe's been acting on climate change for much longer than we have.
Thanks.
If there are other questions or comments, please just unmute and speak right up. In a few minutes, we'll stop this recording. We need to stop it so it will save. And then you'll need to go to the next link for the next lecture. But we've got, we can take another 10 minutes anyway to field questions or comments. One of the things strikes me, Brian, is you mentioned your friend in the little island nation, and that the whole nation is having to plan to move. And aren't we seeing this worldwide, that there's a lot of immigration due to climate change?
Yep, we see, yeah, all kinds of different factors related to the changes we're seeing in the climate system are causing human displacement on a really massive scale. I think the World Health Organization put out a report a few years ago that expected 150 million climate refugees, I think, by 2030, I believe it was. So lots and lots of human displacement, as places become less livable, as they're lost to sea level rise. We see it. Bangladesh is going to see 20 million people displaced because it's very densely populated and very low lying. So these kinds of reality, and that of course contributes to all kinds of other problems too, security problems, a lot of the cultural conflict, and a lot of the conflict around issues of immigration really can be tied to this problem as well.
Sorry, Brian, another question about that last chart.
Yep.
So does that attribute carbon-based energy production to the producer nation or the consumer nation? Do you know? That's probably a technical question. You can tell me later.
That's a good question. I would guess consumption, because, for example, Russia has vast amounts of oil and gas production, and a lot of that goes to Europe. Like a lot of Europe's natural gas comes from Russia.
Yeah.
I'm going to guess that's consumption, but it's just a guess.
Okay.
Yeah, no, it's got to be that, because otherwise you'd have countries like Venezuela would be much higher than it. Venezuela has massive gas production, but their carbon emissions are not super significant because they're not a particularly wealthy country, but they do a lot of exporting of oil. Nigeria, same thing.
Okay.
Hi, this is a little bit of a, I think, a related question. And you may get into this in the next part. The idea of passing on I know we've talked about it. I mean, it's been discussed with food and things, passing on the real cost of something like certain kinds of production, certain kinds of what something really costs. Will you be discussing that in the other part, or do you see some hope on that front that we are addressing that at all?
I am going to bring that up towards the beginning of the next lecture. We're going to talk about externalities and what that is. And then towards the end, we're going to talk about a solution, a carbon fee solution that gets at that. So yeah, we're going to talk about that in the next one, Susan.
Great, thank you.
Any other questions or comments? Well, let's take a break. If you would try to link back in about 5 minutes before 11, that would be great, and we can start right on time. But I'm going to stop this Zoom now, and so run around in the snow for a few minutes, and and we'll see you at a little before 11.